Hey everyone, so I'm going to show you sharding with Bacalhau. We are going to process some videos in parallel. So I've added these three videos to a IPFS network. Let's have a quick look at them. They're just small, quite pleasant videos. Let's look at some calm waves just to say, hey, it's a video file. Here we go. Right. So having that on IPFS, there's a folder of three of them. So here are these three files. Having added that to the IPFS server, we've got a CID right here. So let's get that CID and run a job on Bacalhau. We can see we have a Bacalhau list wide. We have no jobs right now. So let's run a job that processes those three videos into some kind of output. And it will loop over the three videos in that folder one at a time. So let's run that. And whilst that's running, we'll talk about how we might get that to run in parallel with Bacalhau. So Bacalhau docker run, mount the CID of our folder with the three videos. Let's give it a couple of CPUs. We'll wait for the job to complete and we'll time the whole thing. And this job, by the way, just uses FFmpeg to apply some funky matrix style overlay thing. I will not win any Oscars, but it was fun. Okay, so let's set that job off. So off it goes. We have an ID. So whilst that job is running, let's have a look at the state of the world. We can see that it's waiting. We can look at the job's state now, and we can see that there are shards processing. And in this case, there is only one shard because we haven't applied any sharding settings. So we can see that of the three nodes that we have in our cluster, one of them is currently processing the job. Now, the interesting concept would be what happens if we process three shards in parallel to each other, where each shard is a single file. And that's the point of the whole sharding API that Bacalhau now has, is that we can do some work in parallel. So this job at the top here, the sequential, the one after the other, has finished. It took 41 seconds. We can have a quick look at our waves video after that processing. Let's look at the calm waves afterwards, and here is my funky matrix overlay effect. It looks wonderful. Anyway, the job has finished. It took 41 seconds. So the next idea would be what happens if we add some parallelism to this. So let's basically run the same job. It's Bacalhau docker run, two CPUs, same CID, same memory, wait. Here's the key additional part now is we're saying sharding base path is every file in /inputs. Break that up by star.mp4. So our folder, if you remember, has three files in it. Each ending is star.mp4. So that means we now have three atoms based on the glob pattern. Then we say group those atoms into shards of batch size 1. So we end up with three shards. Now what that means is the data set's getting split into three parts. Each part will run in parallel. In practice, this means three videos will be converting at the same time rather than one after another. So let's test this theory and run it. So we have, again, an ID. Let's look at Bacalhau list. We've got two jobs in there now. Let's see what the state is for our job. And we can see that there's bids going back and forth. This time, look, we have three shards rather than one the last time. And we can see on the top, look, the job has finished in 17 seconds because we've been running the conversions in parallel. So fundamentally, the globbing pattern here, sharding glob pattern, is the thing that decides how you shard your job. So you have to make the job suitable to be sharded. So the classic example would be a folder with 10,000 images in it. We could shard that down to 100 groups and run that in parallel. There's a whole world of different use cases. We could combine multiple volumes etc. But yeah, this is just a basic demo of the idea behind sharding and the ability for Bacalhau to run large data sets consisting of lots of files in parallel, so you get stuff processed faster. Yep, that's the demo. Goodbye.